So, this is not quite there right. We're going to look at 3 different approaches that you can take with this. The isosceles triangle theorem states that if you have 2 sides that are equal to each other, then the base angles are equal to each other. What we are going to prove is that if the given information that you have is that the 2 base angles are equal to each other, that would in turn then prove that the 2 sides are equal to each other. So the given information specifically is that we have angle A is equal to angle C. What we are going to try to prove is that side AB is equal to side BC, therefore making it an isosceles triangle. So that's what we are aiming at. And in order to do that, we need to add in some auxiliary lines. So we definitely need to draw another line segment. Now, up until this point, our auxiliary lines have always been connecting 2 vertices. Well, all of the vertices are connected. So when I draw this guy in, I need to be a little bit more specific about how it's drawn. So one of the options that I have is that I can draw BD such that it's 90 degrees. I can draw a height of a triangle. Now, I don't know anything else, but I do know that it's 90 degrees. So we're going to go ahead and do a proof with that information. So we're going to start with that BD is the height of triangle ABC. And we're drawing that, so we're saying we're drawing it. And we're going to say that that is auxiliary lines. So again, I have to be more specific. I can't just say draw BD because D didn't exist, so I didn't just connect 2 points. So that's what I have. Obviously, I have my given angle A is equal to angle C. And obviously, I'm going to have BD is equal BD. Now, if I use that it's the height, then what I can say is I can say, well, the height is perpendicular. So I'm going to say, and I'm going to put 2 more numbers in here, angle 1 is equal to angle 2 is equal to 90, because that is the definition of a height. So if you drew the height correctly, it really is 90 degrees. So based on that information of my triangle, I have congruent triangles. I have, using AS, because the S that I have is not in between the 2 A's, triangle ABD is congruent to triangle CBD. And from there, I can say congruent triangles imply congruent parts. That will give me AB is equal to BC. Congruent triangles give me congruent parts. So, that's one option. That's not my only other option. That's not my only option, though. When I drew BD, I could have drawn it very carefully so that these guys are equal to each other. Now, when I did that, I don't know how it hit here, but I do know it exited this angle by cutting it in. So let me be more specific. I could have this drawn, and I could draw an angle bisector that doesn't cut that in half. It's not perpendicular, but it is an angle bisector. So you can't like combine a bunch of facts. You can just use one fact. So I'm going to draw BD. So it is a bisects angle B. I don't know if it cuts the triangle in half, but I do know that it cuts the angle in half. So that means that I'm going to put 3 and 4 up here. Angle 3 equals angle 4, because that is the definition of bisect. Now, if I did that, I still have BD is equal to BD. I still have these angles are equal, and I still have AAS. I still have AAS, and I still have my 2 triangles congruent, and I still have my sides that are equal. One last option that we could have done is we could have said, well, let's just have D be in the middle. Now, I don't know what it does to that. I don't know what it does here in terms of 90 degrees, but I do know that D is the midpoint. So I'm going to draw BD, where D is the midpoint. So here, what I have is A, S, S. I can't get another S because I'm trying to prove those. I can't get these because I don't know if they're equal to each other yet. I can't get these because I don't know if they're equal to each other yet. So midpoint would not have been a good plan because I would not have the correct information to prove it. So the other two would be the better options.